Comes with different terms. I call it's a symphony of IoT and AI. I say that because IoT does certain things really well. AI does certain things. You have to work in conjunction. They have to work in tandem. If IoT is getting you the equipment health, it is collecting the process data, production data. You have your AI and your ML machine learning and all your analytics, which is going to do a potential failure. Or is this equipment going to likely to failure? What is the prognostics associated with it? Or with this, I'm seeing a pattern. Based on this A, B, C parameters, I'm seeing that this is the most optimal condition in which you are able to operate at the highest production efficiency. So it is critical for IoT and AI to work together. It is not one by itself. Going to the next one, which is the quality side of things, very similar. There are some really, really cool technology. If you take the computer vision based solutions, or you take a laser based solution for looking at your product quality, and then the inaccuracies in the product, or which a visual inspection you may not be able to do, right? It's humanly impossible to do a first pass yield with the highest order with a human or visual inspection. So it is important for you to invest in those technology, the right sensors, but also you got to have a strategy where you can do these insights. There are two things I wanted to mention here. Sometimes you need to go for edge analytics. It is not always cloud first. You can have some of this data flow into the cloud, do some model, but that model goes back to the closed loop, but you do edge analytics right there. Nobody wants this IoT data on the line. When the line is running, you don't want it to go to the cloud, run some algorithm, and then come back. It's too late. Sorry, right? The line is already. So you got to have a strategy for edge analytics, which is where certain thresholds and the parameters or optimal condition under which your product quality is at the best can be decided on the cloud using historical data. But once you have those optimal condition, in order for you to do a feedback loop where you can send this back to your line and then line can adjust itself, that is really critical for us. So you think of the solution as a combination of cloud and edge, or your backend and your edge, and also between IoT and AI. So it's really a symphony and orchestration between both to get to where you need in terms of reducing your cost of poor quality. Moving on to the next one on the stockouts and the material shortage. Again, the it's important for you to have the right mechanism for you to measure the inventory. There are technology solutions which allow you to really do a real-time monitoring of the line speed. How is your material moving, material shortage, forecasting. So you need a combination of both AI and IoT or your sensors, which can get you the right metrics in terms of the shortage supply. Moving on to the next one. So personalized recommendations, AI has its own role by knowing what type of problems are faced based on the persona, based on some of the advanced technology, allowing them to do most complex operation using AI, your virtual reality, AR technology. Doing some simulation is extremely critical, because which otherwise it would put your workforce in a very complex or hazardous environment, but also you're actually training them with the latest and greatest technology. And go to the next one. The equipments, as we said, how do we coexist with the legacy and the modern system? That is really a critical aspect when it comes to the technology and the machinery. So it is always important for us to strive for a single source of truth. It is not uncommon I've heard this many times. We don't have a part master, or we have got three sources of part master, right? Scrap codes. Oh, every plant has their own list of master scrap codes. Quality codes, reason codes. Yeah, we've got our own thing. Oh, this continuous improvement team wants, and which continuous improvement team? Every plant has their own line. So it's important for you to have a master data strategy and then how do you cascade that all the way to the front end. And even in terms of the predictive maintenance and being able to have a just in time notification, so that certain replacements, certain repairs, and certain maintenance can be done, not based on your time based maintenance, based on the condition based maintenance, is really key. So that is where it's really a combination of IoT can tell you some of the metrics, your process control parameters, your production data parameters, but then you need to have your algorithm in place to operate on it so that you can make the right decisions. Last but not least, you might have seen many use cases where there are computer vision technology, there are indoor geofencing which can keep our workers safe. They are not super complex solutions. Some of them are really simple solutions, which is not futuristic. It might look like a very futuristic solution out there, but they are implementable. They are benefits are real, and you can see it in action. And they don't cost a lot. It really requires a strategy and study so that you can implement for your unique needs, because every plant has unique needs. How you geofence certain areas, what is considered hazardous, and how can you detect certain things right then and there, instead of expecting people to do the right thing, which most of them have the right intent, but different circumstances causes the 20% of fatalities what we see.